Ammonium oxalate and mercury 2 phosphite yields what? There are two reactants, both are compounds, so this could be either double replacement or synthesis. Both are ionic compounds, so this must be a double replacement reaction. We start by writing our ammonium ion and our oxalate ion. We need their charges so that we can crisscross to make sure that we get the formula written correctly. There end up being two ammonium ions. Next, we write our mercury 2 phosphite. We start by writing the mercury and our phosphite ion. Now it says mercury 2, so we have a 2 down here, right? No. Stop doing this. There are not two mercuries. Mercury 2 means its charge is 2. The phosphite ion is a -3, so when we crisscross, we end up with Hg3 and our PO3 in parentheses with a 2 after it. Now we need to see what it yields. We'll turn to our reaction rules. For a double replacement reaction, oxidation numbers remain the same. We just swap either the positives or the negatives. We'll start by writing our ammonium ion, and we'll put it instead with the phosphite ion, like this. We need their charges so that we can re-crisscross, and we end up with 3 ammonium ions. Next, we write our mercury 2, and we put it with the oxalate ion, C2O2. Both of them have a +2 charge, and they cancel each other out, so this is the correct way to write this one. Lastly, what we need to do is balance the equations. On the left-hand side, we see that there are 2 ammonium ions, and there are 3 ammonium ions on the right-hand side of the equation. We can't turn an even number into an odd, but we can turn an odd number into an even by multiplying the ammonium phosphite by 2. That means we have 6 ammonium ions. We'll need to multiply the ammonium oxalate by 3 to have a balance. That'll give us 3 oxalate ions, so we'll need a 3 down here. Lastly, our mercury 2 ion, there are 3 of them on both sides, so the equation is now balanced. The result of our original question, ammonium oxalate and mercury 2 phosphite, is that it yields ammonium phosphite and mercury 2 oxalate.